You're likely to be faced with a couple of questions about rebreathers in the equipment instructor theory exam. So here is the basic information you need to know. A rebreather contains two tanks, a tank of oxygen and then a tank of either air or trimix. That would depend on how deep you're planning on diving. So with open circuit, when we exhale, our exhalation goes into the water surrounding us, which is why, of course, when we exhale, we descend slightly, and when we inhale, we ascend slightly. With closed circuit, the air we're exhaling stays within the system, and it passes through a scrubber that removes the CO2 from our exhaled breath, allowing us to then safely rebreathe it. And there is a set of external lungs that our exhaled breath goes into, which means that with exhalation or inhalation there is no real effect on our buoyancy because the air we're breathing is circulating. This means when diving closed circuit, buoyancy is controlled through BCD inflation and deflation. Thinking about the electronics that are in a rebreather, one of the important things is a way to monitor the levels of CO2 that are in the breathing loop. The diver needs to be able to make sure that the CO2 levels are being kept safe. CO2 is an absolute silent killer. And the other killer that we've talked about in other videos is oxygen toxicity, having too high an oxygen partial pressure. So within a rebreather you have an oxygen sensor, and it will also always have a way of knowing what depth you're at, and using the percentage of oxygen in the breathing loop and knowing its depth, the rebreather will always know what the partial pressure of oxygen the diver is being exposed to, and that avoids oxygen toxicity. So the diver can actually tell the rebreather what oxygen partial pressure they want to be exposed at different points during the dive, usually a lower oxygen partial pressure for the surface and descent part of the dive, and then a higher oxygen partial pressure, commonly 1.3 atmospheres for the main part of the dive. How does it achieve that? Well, of course, we're now coming back to the two tanks that are inside it. If it needs to increase the oxygen partial pressure because we've ascended, it can squirt oxygen into the breathing loop. If the oxygen partial pressure is getting too high because we've descended and we're under a greater pressure, then it can squirt air or even trimix into the loop to reduce the oxygen partial pressure the diver is exposed to. So all these electronics allow the rebreather to change the ratio of gases the diver is breathing to ensure that the oxygen partial pressure remains safe, remains within the parameters set by the diver as part of the dive planning. That is very different to open circuit, where we just have one tank of air. The ratio of gases are fixed when we fill that tank, so the partial pressures we're exposed to during the dive change with depth. So some key points to remember about the differences between rebreathers and open circuit is that when you're diving open circuit, you can use a combination of your lungs and BCD inflation deflation to control your buoyancy. With a rebreather, buoyancy is only controlled using inflation and deflation. The other thing is the ratio of gases. With open circuit, the ratio of gases remains constant throughout the dive. With closed circuit, the ratio of gases the diver breathes can be changed by the system to maintain a desired oxygen partial pressure. So if these videos are helping you study for your exams, please hit the subscribe button and visit my website www.goprocaribbean.com, where some of my most useful videos are exclusively hosted.